It's envelope time. Most envelopes that you find are ADSR, or attack, decay, sustain, release. For simplicity's sake, and because modular doesn't use decay or sustain nearly as much as a keyboard synth would, we're making an AR, or just attack, release. Attack being the amount of time it takes to get from 0 to our max value, and release the time it takes to go back down. A short attack sounds like a piano key being hit, and a long one sounds like a brass instrument slowly getting louder. You don't need to apply the envelope to just volume either. You can apply the envelope to any tunable parameter on the synth and get an interesting effect. So let's get started on the basic outline here. We want an output jack, an input knob and jack for both attack and release, and a gate input that will tell the module when to generate its envelope. I'll also add a button to manually trigger the gate. It's really useful for testing, and also a switch to toggle between gate mode and trigger mode. In gate mode, the envelope goes up while the gate is on, and down when it's off. Trigger mode just detects the first pulse from low to high and does the whole attack and release independently. For something like a melody line, gate mode is useful because it lets you hold on to notes and control exactly when you think they should decay. Trigger mode works better for stuff like percussion, where you want precise and consistent envelope. Having both here will be really useful. The wiring here is even more of a mess than usual, but the key takeaway is that each component gets one wire to an analog pin and another wire to ground. Our button has a built-in LED that we put 3.3 volts to, and I was scared about whether or not to put a resistor in line here, but the datasheet says that it has an internal resistor in it already, so I don't have to worry about it. We live in the future. I'm skipping over the wiring for the button for now because I totally did it wrong here, and there's some pretty involved debugging in a second, so I'll wait till then. For now, let's ditch this jumble of wires and escape back to software land, where everything is nice and clean. There's a lot of initialization logic here that you can mostly ignore, and we can get into the confusing stuff. It looks a little crazy at first, but the overarching logic here is pretty simple. We have a main loop where each frame we start by calculating some values that we'll use later on. IsGate checks if either the button is pushed or our jack is above some threshold value. Then attack and release delta are the amount we want to change our signal by if we're attacking or releasing. We're only going to be using at most one of these per frame, so you could technically optimize this by only calculating the one we need, but that seemed confusing, and I want to prioritize readability. Optimization can come later, if it's needed. Moving along, we have two different modes that we can be in, either gate or trigger, and so we branch off into two different directions based on which one the switch is set to. Gate mode is pretty simple. If isGate is true, we want to attack. If not, release. Oh, and turn on the light. We don't account for overflow here, so we need to make a mental note to clamp our output value later on. Trigger mode is just a little bit more involved and took me a while to think through. It boils down to be not too complicated. There's just a separate isGate activated, which has the same function as just the isGate from earlier. Then there's a has button been released, which makes sure the signal goes low again before we can trigger isGate activated again. Then we go back to our mental note from earlier and add a min and max to clamp our out value, and we should be good to go. Oh, there is one thing that I glossed over earlier. How do we translate a knob and input jack value into an amount to increment or decrement in each frame? And like most things in life, it's a mixture of formal equations and wild guess and check. After playing around in graphing software, I ended up with a 1 over 1 minus 10x, which I can't say too much about besides it just sort of feels right. After some quick tests with the TTY output that look encouraging, it's time to move our schematic over to the proto board. Just the same setup as before, but now with a bit cleaner wires and a bit more permanence. I'll deal with the button and switch later. They aren't surface mount components, so I'll solder them in manually to the back of the board once we get everything else situated. Measure/eyeball some holes for the enclosure, and let's get to drilling. You know what they say, measure once, you drill once. Teach someone to measure, they'll be drilling for the rest of their life. If you, for whatever reason, happen to not mark the correct positions when drilling these holes, you can always just widen the holes until everything does eventually fit. I like to think it's not a mistake, it's stylistic. And speaking of style, it's painting time. Today is this really cute light blue. It's very light, so I have to do a couple different passes to cover it completely. And I don't know if it's the fumes from the nail polish or painting itself that's just naturally a relaxing task, but I always feel so calm after doing this. It's a nice little break. Okay, and now we're back to attaching our button and switch to the proto board. With everything else assembled, we can just run wires on the back of the board to the pins we need. Both the button and the switch hook up to digital input pins, and the light for the button to a digital output. Then 3.3 volts in ground because the components ask for them. And there we go, a finished looking module, but I think it still might be missing something. Oh yeah, there we go. The label maker makes me feel so much more professional, but then the googly eyes sort of level it back out, so I think I'm back to square one. Anyways, let's try out our new module with our newly decorated modular synth. We can hook up our new envelope module to the voltage-controlled amplifier we made last time to generate a note sound when the gate is active. We can control the gate with our randomness module so it triggers randomly. And that's it. Next time we're making a clock, and maybe we'll start getting something that sounds closer to music even. Thanks for following along, and I'll see you next time.